Welcome to homework.
Okay, so in this problem, we're given a frame that has a force F acting on its point B. So in the diagram, you can see force F is acting downwards from point B at some angle that we don't really know. We're also told that a force acts along AB, so this line right here, and this force is 650 pounds. Next, we're told that a force acts on BC, and we're told that this force is 500 pounds. Okay. What we're tasked with is finding the magnitude of F and its direction that we don't know yet. We are given a few other angles. The first is this one here, which is 60 degrees. And we're told that this angle over here, right here, is 45 degrees. And so what we need to do is create a triangle because we have two forces that are contributing towards a larger force or one central force. So we create a triangle, and to do that we can actually shift this line right here over and imagine just shifting it to create a triangle there. And we're actually going to draw a larger version of that triangle so we can see what's going on. Okay, just so we can see. So now, although this line is F, it's a force that we don't know yet. This line up here is 650, and this line down here is 500. Now, we can actually figure out this angle, and it's because of the angles that it gives us. So, if you can imagine taking this angle right here and moving it up to fill that line. And it actually works because this orange line that I just drew is parallel to the baseline of the triangle. So in the top half of the triangle, the second triangle we just made, is 60 degrees, and the bottom half is 45 degrees. And although my drawing is a little bit misleading because it's definitely not near those numbers. But we know that that angle is going to be 60 plus 45 degrees. So this angle is 105 degrees. Now that we have two sides and the angle between those sides, we can actually apply the law of cosines. And I'll write that out real quick. That law is c squared equals a squared plus b squared minus 2 ac times cosine, parentheses, cosine of the angle c. So in this case, we're solving for f. So f is actually going to be our c squared. So I'll write that in as f squared equals, and our other two side lengths we know to be 650 and 500. So we can just fill those in for a and b, and rather, I wrote c here, this should be b, sorry, okay. So 2 times 650, 500 cosine of c, and the angle c is 105 degrees. So if you punch all of this into a calculator, you should get, let me just do this really quick, f squared should equal 840,723 approximately, and to find f, we square both sides, and f comes out to about 917 pounds, because that's the unit we're given. Okay, so now we have the force, but we need to find the angle between the force and side AB, which is actually that angle right there. And we can actually use the law of sines here, which is this right here. So A over sine of the opposite angle of that side equals B over sine of the opposite angle of that side. So we can apply this exact thing to these two sections. So using the force we just found, 917 over sine of 105, this is equal to 500 over the sine of an angle we don't know, so we'll call that theta. I'm going to simplify this really quick, and this should come out to, let me just double check this. Theta should come out to 30 31.8 degrees. And there we go. So our final answer is that the force is 917 pounds at an angle of 31.8 degrees from line AB.